So we have written it down this in the form of t functions, t minus n, t minus 1 and u t minus 1. So this is a Laplace transform of in the form of so for example the Laplace transform of this will be t square. This is a t square term, so t square term the Laplace transform is in the form of 2 over s cube. So I will write it 1 over 2 is here over here into it's s cube over here, 1 over 2 s cube, and for u t by t minus 1 it will be e power minus s. It will be e power minus s. So for the next term it is t minus 1, so it is t, so for t it is 1 over s square plus 1 over s square, and then it will be e power minus s. And the last term is only 1 over here. So for example 1, Laplace transform is 1 over s, so it is 1 over 2, because 1 over 2 is from here, then it will be e power minus s. Okay, so for the next term, which was this 1 over 2 t square u t minus pi by 2. So 1 over 2 t square u t minus pi by 2 pi by 2. So in this case we can write 1 over 2 t square, so 1 over 2, and then we can write this t in place of t, we can write it like t minus pi by 2 square, and since it has to be t square, so therefore the expanding terms must be cancelled out. So the middle term will be, it is actually t square minus pi t, so it should be added as pi t. We should add as pi t over here, and then it is pi square over 4, so we will subtract pi square over 4. So it will be u t minus pi by 2. We will further standardize it. So this t should be also pi minus 2, t minus pi by 2. So now it is pi t minus pi t by 2, so pi square by 2. So it is actually pi square by 2, it is pi square by 4, it should be pi square by 4. So minus pi by 2, and then if I add pi square by 4, so then it will be minus pi square by 4, because it will be minus 1 by 2 plus 1 by 2, which is actually minus 1 by minus 1 by 4. Okay, so u t minus pi by 2. So now we have made it into the standard form. So t minus pi by 2 into u t minus pi by 2 is, so this is t square. So for t square we have this one s cube. Okay, and then it should be for this e power minus pi s by pi by 2 s. Okay, and this is a t term, so it should be pi is here. For t term it is over s square. the Laplace transform, and the Laplace transform for this term is pi square over 4s. And yeah, here I just forgot to put 2 over here because it is actually 2 factorial over s cube. Okay, so this is the Laplace transform of this term, and the next term is here, this one, cosine t u into t minus pi by 2. So this is the cosine of t times u t minus pi by 2. So cosine t have to be written into t minus pi by 2 term. Okay, and so what is cosine t is equal to cosine t minus pi by 2? So this we can verify with the help of this triangle. If it is a side, if it is side A, this is side B, then if it is side C, so sine of t is actually cosine of t is actually b over c, and if it is angle t, so this angle will be pi by 2 minus t. So sine pi by 2 minus t will be also b over c, right? So it means that cosine of t is equal to sine of pi by 2 minus t, or in another word, cosine of t is equal to minus sine of t minus pi by 2, because we know that sine pi by 2 minus t is equal to minus sine t by t minus pi by 2. This we can even verify it. Okay, I mean, or we can actually this, because sine is a odd function, so if we take the negative of this, then that negative will come out over here. So therefore here we can write it like this. So instead of this, instead of cosine, we can write it as a sine t minus pi by 2. So it is u t minus pi by 2. So for this sine, we know that for sine omega t, it is omega over s square plus omega square. So in this case, we can take this sine of t omega with and then its Laplace transform will be considering only sine t, that means omega is equal to 1, so it will be 1 over s square plus omega square. Okay, and for this it will be e power minus pi s by 2. Okay, here it was minus, so it should be minus over here. You see over here it was it was plus over here. Oh, okay, so sorry, the minus sign was here. The minus sign was here because cosine of t is equal to minus sine t minus pi by 2. So it should be a minus sign here. So that minus will come here. So in this way, then I can write down the function, this is the Laplace transform of function t as the sum of all these previous terms which were calculated. So what were those terms? One of the term was this, and the other term is this. Okay, so it will be 2 over s minus 2 e power s minus over s. So it is 2 over s minus 2 over s e power minus s, and then the next few terms were these terms. Okay, so plus 1 over s plus 1 over s cube. Yeah, even here I think I should have put s cube 2 over here, so 2 will cancel with 2, so it should be, then the term will be 1 over s cube plus 1 over s square plus 1 over 2s into e power minus s. And yeah, this one, and the next term was this one here. So plus 2 cancels with 2, so it will be 1 over s cube plus pi over s square plus pi square over 8s. Here, yeah, pi square over 8s. Here actually, I forgot to put 1 by 2 with each one. Okay, so 1 by 2 have to be multiplied, so it should be 8s. So pi over 2s square and pi square over 8 into over 8s, and the last term was this 1 over s square plus omega square. Omega was actually 1 over here, 1 s square plus 1 and e power minus pi s over 2, and here also e power minus pi s over 2, pi s over 2. So in this way we have found out the Laplace transform of this function. So what was the function? Function of t was 1 over 2 t square, and then cosine of t for, it was like 0 to t is minus 1, and it was from 1 to t to 2, and then t is greater than 2. It was something like this, if I remember, long time ago. Yes, so it was this pi by 2. It was not. It was pi by 2. Okay, so this was the Laplace transform. So next example I will show the inverse Laplace transform. So how to calculate the inverse Laplace transform.